Good morning, guys. Today we're going to look at multiplying and dividing rational expressions. We may ask, what is a rational expression? A rational expression is an algebraic expression that has a polynomial in its denominator. So when we hear denominator, we think fraction. When we hear polynomial, we think positive integer coefficient or exponents. So it's just got variables in the denominator that have whole number exponents. Now, when we talk about working with rational expressions, we're actually looking at working with rational numbers. Rational expressions follow the same rule as rational numbers. So if we talk about reducing a fraction, multiplying, dividing, adding, or subtracting, the same rules that we use for rational numbers, we're going to use for rational expressions. Because remember, a polynomial expression is just a relationship of variables and coefficients to create an actual number. So we're realistically working with a rational number in a rational expression, number divided by number. Now, if we look at reducing, let's go over just how to reduce. You usually think to yourself, when I reduce a fraction, what number divides into each of them? Well, I could look at this numerator right here and the denominator 6 and 8 and know both of those divide by 2. So you may have written it divide by 2 equals 3 over 4. So 6/8 reduces to give us 3/4. Now, that's usually what the thought process is, but I want to change that up a little bit. I want to actually look at this as a factorization, because that's what we're doing when we say what divides into both of them. What we're doing is saying what factor is common to both of them. That way it ties into what we've been working with the factor. So instead of saying what divides into both of them, saying how can I factor this down? So 6 would factor into 3 times 2. 8 would factor into 4 times 2, and it would actually factor into 2 cubed. So as we're working through this, 3 times 2 over 2 cubed, when we reduce a fraction, all we're really doing is canceling factors that are common to both the numerator and denominator. So 2 on top cancels with one of the 2's in the denominator. So 2 and 2, remember we subtract that exponent because it canceled out. So I get 3 over 2 squared, which is 3/4. Now, I know you're sitting there saying, well, why did he do that? He made a lot more work instead of saying divided by 2, divided by 2. And the reason is this is algebra. This is conceptually what's going on when we reduce a fraction, when we say both of them will divide by 2. So I want you thinking of it in this terms, because when we start doing polynomials for those numerators and denominators, it's a lot more difficult to say, what can I divide both of them by? What is that common factor? What if I'll get in the habit of factoring and just looking, and then I can see what the common factor is? Then it's a lot easier to reduce your fraction or simplify your rational expression. Now let's look at multiply. To multiply fractions, remember we just put the numerators together, put the denominators together. We always say multiply straight across. So if I'm going to multiply these, I'm going to put 1 times 6, which gives me 6, 3 times 5, which gives me 15. Then, after we multiplied, we would reduce our final fraction. So what I'm going to do is the same thing I did here. We're going to factor it down. Use a marker. We're going to factor it down. 6 is 2 times 3. 15 is 5 times 3, so I can see the 3's cancel. Gives me 2/5. Using that same idea of factor and cancel the common factors. Here we have a division problem. 2/5 divided by 4/3. We remember that dividing is the same thing as multiplying by reciprocal. And that goes back to our negative exponent rules that we had talked about before. So dividing is the same thing as multiplying by reciprocal. So I'm going to change 2/5 divided by 4/3 into 2/5 times 3/4. Now we multiply. Multiply your numerators, 6. Multiply your denominators, 20. Then we reduce. So 2 times 3 over 4 times 5, which is 2 squared times 5. So 2 and 2 cancel. So I get 3 over 2 and 5, which is 10, 3/10. Lastly, we're going to look at adding and subtracting rational expressions. When we add or subtract, remember we're just counting how many of this specific denominator we have. 1/5 plus 1/5 gives me 2/5. How many fifths do we have? 2/5. 4/7 plus 6/7. How many sevenths do we have? 10/7. So when we add or subtract, we need to have the same thing so we can count how many of that actual item we have. So I have 2/5 and I have 3/10. So I'm going to use this idea of counting what I have. Well, they're different. So how do we make them the same? Well, I can say both of those will multiply, or both of those are a factor of 10. So I can multiply this left-hand side by 2. If I do it to the denominator, I do it to the numerator also, keeps that fraction balanced. So I get 4 over 10 minus 3 over 10, which is 1/10. So we identify what that least common denominator is, and then multiply that out. Now let's change how we look at that. Instead of just saying, well, what can 10 and 5 both go into, let's just look at what makes 10. If I was to take this and not look at it as 3 over 10, but instead, in its factored form, 3 over 2 times 5, if we want a common denominator, the denominators need to completely match. So I can already see they have a 5 in common, so what did I need to put on the left denominator to make the denominators the same? I needed to give it a 2. So now I have a 2, 5 for both denominators, and that's how we get a common denominator. So we use this concept of making the denominators have all of the same factors, make them identical, then they're common. Then we can just combine those numerators. We can count on how many tenths we have. So I had 4 tenths, I took 3/10 away, so that left me 1/10. And so these rules right here, this process that you've done since the 6th grade or whenever thereabouts for adding and subtracting fractions or doing fraction arithmetic, is the same thought process we're going to use a rational expression. So we're going to throw some variables in there, but we still want to keep that same idea. Okay, next, let's start looking at simplifying some rational expressions. This is what we mean when we're talking about a rational expression. It's a fraction, it's got polynomial in the denominator. To simplify a rational expression, just like we talked about with the fractions before, we want to see what's in common both the numerator and denominator. So we're going to start by completely factoring both the numerator and denominator. Once we've done that, whatever factors are in common, we can cancel out. So then I'm going to reduce any monomial factors, that would be like common factors that we pulled out. And then we're going to cancel any polynomial factors. So that would be binomials, trinomials, whatever may remain. We can just cancel those out if they're the same. So reduce any monomial factors, cancel any polynomial factors that are in common. Very important. Has to show up in both the numerator and denominator to pick that, to cancel that out. So, let's start right here. 12x to the 4th minus 4x cubed minus 8x squared. So we're going to factor that. Initially, we're going to look for a common factor. All of them have at least an x squared. All of them will divide by 4. So we have a common factor of 4x squared. So that's going to leave me 3x squared minus x minus 2. Then let's look here. I have a common factor of at least an x cubed. All will divide by 2. Okay. So we've got 3x squared plus 8x plus 4. So there's my monomial factors. We'll reduce them in a minute, but we need to finish factoring this quadratic trinomial out. So we get 4x squared, 2x squared, and we know quadratic trinomials should factor into a pair of linear binomials. Break up the first term, 3x and x. Break up the last term. So let's try plus 2 and minus 1. Then we check to see if it gives us the middle term. So positive 2. Negative 3 gives us the negative 1x, so we factored that correctly. Break up the first term, 3x and x. Break up the 4. Let's try 2 and 2. 2x plus 6x gives us the 8x we need for the middle. So now that we've completely factored it, let's do the actual reducing here. So 4x squared over 2x, over 2x cubed. 4 over 2 reduces to give me 2. X squared over x cubed reduces to give me an x in the denominator. And are there any polynomial factors that are in common? Yes, we can see right here 3x plus 2 and 3x plus 2, they would cancel out, and that would leave me just an x minus 1 and an x plus 2. So this is our final simplified form. Now, whether we leave it as this or we redistribute and do 2x minus 2 over x squared plus 2x, that really just depends on who you're talking to. This is never, keep in mind, this is never a final step in any kind of a math problem. This is usually just an intermediate step, and we're then going to do something with this simplified expression. So leaving it in this form is okay with me. You may have a teacher at some point that wants you to redistribute and combine like terms and actually make that look like 2x minus 2 over x squared plus 2x. That's what I'm talking about when I say redistribute, combine like terms. But again, it's a personal preference of whoever the teacher is, and you'll know that once you actually start doing some math, when you need to leave it factored and when you don't. I think our text leaves it in this factored form, so we'll go with that for now. But that's reducing or simplifying a rational expression. Again, it's just factor the numerator, factor the denominator, cancel any factors that are common to both. Now we're going to look at how to multiply rational expressions. So it's going to go back to like we did with rational numbers. You're really just combining the numerators, combining the denominators, and then reducing your fraction. So we're going to start by completely factoring each numerator and denominator. So for example, in number 1 here, when I go and completely factor each numerator and denominator, right there, we have a quadratic trinomial for this first numerator, so we know that that's a pair of linear binomials. So that's going to be 2x and x. 1 will be plus 1 plus 1. So when we check it, 1x and 2x gives us 3x. Have a difference of 2 squares right here, so we remember that factors x squared is x and x. 4 is plus 2 and minus 2. Call those conjugate pairs because they have the same terms but opposite signs on the second term. Over here, again, a quadratic trinomial, so a pair of linear binomials, x minus 2 and x plus 1. X squared is x and x, negative 2 is negative 2 and positive 1. Negative 2x plus 1x gives us the negative 1x. Here we have a common factor problem. It's 2 terms, both of which have a factor of 3x. So when I factor 3x out of there, I get a 2x. Factor 3x out of there, I get a 1. Now we're going to go to the next step, which is where we actually multiply or combine the numerators, and then we multiply or combine the denominators. So when I multiply, this is the trickiest math step ever, so pay close attention. You ready? Here we go. We're going to multiply. There we go. That's it. There's my numerator, there's my denominator. Because remember, a multiplication of rational expressions, a multiplication of fractions, is just a product of the numerators over a product of the denominator. So really we're just writing that as one large numerator over one large denominator. Now it's the simplify step, which was reduce the monomial factors, which 3x was the only monomial factor we had. Okay, so there's 3x, it'll stay in the denominator. Then we're going to cancel any common polynomial factors. So what's in common? I've got a 2x plus 1 for the numerator and denominator, so it's out. I've got x minus 2 for the numerator and denominator, so it's out. We've got this x plus 1 and x plus 1, but we don't have one on top and one on bottom. Remember, the reason they cancel is because I have a number, I'm dividing it by itself, so it leaves me 1. Well, this is a number times itself, so it actually ends up being that number squared. So x plus 1 and x plus 1, I have 2 x plus 1s there. And then we have this x plus 2 that's hanging out down here in the denominator by itself. So this is our multiplied, simplified form of this. Now, one thing I forgot to talk to y'all about on the last, when we were talking about just simplifying in general. Remember, we have this rule that we can never divide by 0. Denominator of a fraction can never be 0 because you can't take something and divide it into 0 parts. It's not possible. So what we have to do when we have variables, variables mean I could have any x, any number thrown in there for x or y or whatever variable we're working with in our denominator. When that's the case, we have to put restrictions. We have to state what things x cannot be. Because if x were to come in and give us one of these things that made it 0, you get something really nasty. First, the math police show up and they lock you up for dividing by 0 because you just created a black hole in the middle of the school. So we can't divide by 0. So we have to make sure that anybody that sees this problem after us knows what things we cannot have plugged in for x. So, what is a restriction? It's anywhere that the denominator factors would equal 0. And we remember that from the zero product property. If one factor of a product is 0, then the entire expression is equal to 0. So, anytime one of these numbers, one of these factors would equal 0, then it would make the entire denominator equal 0. It makes the entire expression undefined, and we don't want that. So, we're going to state our restrictions. So we have to state what things x cannot equal. What x cannot equal. Now, again, just like before when we were talking about, do I redistribute combined like terms or do I leave it in this factored form? Exactly what we state restrictions on can depend on who it is that you're talking to. Some people will only state restrictions on things that cancel out. Because right here, this should be obvious. X cannot be 0 because 3 times 0 times all this other stuff would make 0. This should be obvious that x cannot equal -2 because -2 plus 2 is 0 times anything else is going to make it equal 0. So these we can still see. They should be obvious. So some people won't state the restrictions that are there. They'll only state restrictions on the factors that cancel out. I want you guys to go ahead and state it on everything. We'll just get in the habit of if it shows up in a denominator at any point in the process, then we need to say that it is a restriction. So I always look right back before I did any canceling, and I can see 0, okay, because 3x cannot equal 0, divided by 3, so x cannot equal 0. Okay, so x is not 0. I've got x plus 2 can't equal 0, so x cannot equal -2. Got x plus 2 equals 0, so x minus 2, getting ahead of myself. So x cannot equal +2, so that's plus or minus 2. And then we have the 2x plus 1. Cannot equal 0, so 2x cannot equal -1, x cannot equal -1/2. So this ends up being the restrictions. This entire thing is our answer. And we should realistically do that anytime we're working with a rational expression. We would do it on the simplifies. I just sometimes get focused on the simplifying and forget what's going to keep y'all out of math jail, which means we're not divided by 0. We need to make sure no one else does. So this is how we go through and multiply rational expressions. Factor each numerator and denominator, put those numerators and denominators together, and then it's a big fraction, reduce. Cancel any common polynomial factors, reduce any monomial factors, and then state your restrictions. Tell me what things showed up in a denominator so we can make sure that they don't make it equal 0. Okay, now we're going to look at how to divide rational expressions. We know that if we don't really divide fractions, we use this idea that change it to multiply by the reciprocal. So it's the same thing with rational expressions. Anytime I see division with rational expressions, my first step is always going to be change it to multiplying by the reciprocal. So we don't divide by a fraction, we multiply by the reciprocal of that fraction. Now once it's a multiplication problem, it's just a multiplication step. Completely factor each numerator and denominator, put the numerators together, put the denominators together, simplify, and state restrictions. So let's look at the example we have here. First step is always change it to multiplying by the reciprocal. And a lot of people get confused. Do I flip both fractions? Do I flip the first fraction? Do I flip the second fraction? Listen to what it says. Instead of dividing by a fraction, well, which one are we dividing by? We're dividing by the second one. So instead of dividing by a fraction, we multiply by its reciprocal. So instead of dividing by this second fraction, we're going to multiply by the reciprocal of the second fraction. So it's always the second fraction that we change to its reciprocal, that we flip over. So 2x squared minus 5x plus 2 over 5x minus 20. Now it's a multiplication problem. Factor everything. X minus 4 is already factored. It's a binomial. It's first degree. There are no common factors. So just because we're going to be doing a lot of combining, I like to take things that are already factored and go ahead and group them in a set of parentheses so I can remember what, not to get them confused with some terms later on. So x minus 4, this denominator, I have a quadratic trinomial with no common factors, so we know that should give us a pair of linear binomials. 3x squared is 3x and x. Negative 4 is probably going to be plus 2 and minus 2. Check it. Negative 6x plus 2x gives us the negative 4x we need. Over on the right-hand side, again, a quadratic trinomial is a pair of linear binomials when we factor it. 2x squared is 2x and x, and 2, I believe, comes out to be negative 1 and negative 2. So negative 1x, negative 4x gives us the negative 5x we need for the middle. And here, what kind of factorization are we going to use? It's a binomial, it's first degree, but we have a common factor of 5. So it's x minus 4. Now we go into our multiplication step. So we're going to put everything together. So we just make it one big fraction, combine the numerators, combine the denominators, and see now why we put this in parentheses. That way we can see all the individual factors. What's going to cancel out? X minus 4 will cancel. X minus 2 will cancel. So we're going to be left with 2x minus 1 over 5 times 3x plus 2. Last step, state those restrictions. What can x not equal? Well, it can't equal negative 2/3. Remember, set each factor equal to 0 and solve. Subtract 2, divide by 3, so negative 2/3. Can't equal positive 2. Giant comma right there. Can't equal x minus 4. So x is equal, so it can't be 4. And a lot of people will be like, can't equal 5. Well, think of it. 5 equals 0. Well, 5 cannot equal 0. Well, that should be obvious because 5 is never going to be equal to 0. So constants, that means things that don't have variables, whether it be a term or a factor. Constants can never be equal to 0. So we don't have to put x cannot equal them. We only are worried about the factors that have x's in them. So I don't have to put 5 down here in my restrictions. So this ends up being our final quotient. That's when we put together two expressions by division. So whether it be simplifying, multiplying, or dividing, it all comes down to factor, cancel what's in common, and then we're going to use our rational number rules for putting together by division or multiplication. I'll see you in class tomorrow, guys.